Hello students, welcome to Sankalp Learning. In our last session, we were discussing about the MCQs, okay, on amines. So, as we have discussed, the total marks allotted for this chapter is 8 marks, okay. So, 1 mark you are going to get 3 MCQs and 5 mark 1 questions, okay. So, we have stopped the MCQs in between, okay. So let us continue that. Okay. So this was a question which we were about to start. So the question is, ethylamine when treated with nitrous acid gives you. Okay, so ethylamine when treated with nitrous acid gives A ethylamine, B methylamine, C ethyl nitrous acid, and D ethane. So ethylamine CH3, okay, NH2 when treated with nitrous acid, okay, HNO2 acid, okay. So what you are going to get? So what will be the answer, students? What I'm going to get? So ethylamine, when you react it with your nitrous acid, I'm going to get a ethanol, okay, or that is a ethyl alcohol, okay, ethyl alcohol plus N2 gas is released plus water. Okay, so our answer is ethyl alcohol. So option number A. Okay, option number A. Yes. Let us go for the next one. Solubility of ethylamine in water is due to solubility of ethylamine in water is due to, yes, A, low molecular weight, B, ethyl group present in ethyl alcohol, C, formation of hydrogen bonding with water, and D, being derivative of ammonia. Yes, so what is the solubility of ethylamine in water is due to? What is the reason? While ethanamine, okay, it is soluble in water. What is the reason? Yes, it is due to what? It is due to the formation of hydrogen bonding. Okay, so when you put ethanamine, okay, in water, so H2O, right? So what will happen? Your your hydrogens, okay, and your oxygen, right? So you are also there is a nitrogen. So your electronegative atom like nitrogen, oxygen, right? They form the hydrogen bonding with your hydrogens, right? So you can see that it will form what? It will form a hydrogen bonding. Okay, so it can form the hydrogen bonding. So the ethanamine, they are soluble in water. The reason is because of formation of hydrogen bonding with water. Okay, so option number C is the answer. Okay, let us go for the next one. Nitration of aniline in the strongly acidic medium at 298 Kelvin yields. So when you do a nitration, okay, when you do the nitration on your aniline, okay, so let me write the structure. So this is aniline, okay. What I'm going to do, I'm going to do nitration. Nitration is carried out in the presence of concentrated HNO3 plus concentrated H2SO4. Okay, concentrated HNO3 and concentrated H2SO4 together is called as the nitrating mixture. Together they are called as what? They are called as the nitrating mixture. So at 288 Kelvin, okay, you are going to obtain what? I'm going to get a ortho para and ortho, para, and your meta products. Okay, ortho, para, and your meta products. So this is your orthonitro, this orthonitroaniline, paranitroaniline, and metanitroaniline. So we are going to get a mixture of nitroanilines. Okay, I'm going to get a mixtures of nitroaniline, that is ortho, para, and meta. Okay, so when you carry out nitration of aniline in strongly acidic medium, okay, strongly acidic medium, I'm going to get what? I'm going to get ortho, para, and para, ortho, meta, and para nitroaniline. Okay, let us go for the next question. Nitration of aniline is carried out after acylation because nitration of aniline is carried out after acylation because A. Acylation deactivates the NH2 group. B. Oxidation can be prevented. C. Ortho and para products are obtained in group yield. And D. All of this. So nitration of aniline is carried out after acylation. What is the reason why nitration of aniline is carried out after you are acylating the product? Yes, what is the reason? Because the acylation deactivates your NH2 group. Okay, so if you do acylation first, okay, so your NH2 group will be what? It will be protected. Okay, it will deactivate the NH2 group. So a nitration of aniline, it is carried out after the acylation only. Okay, yes. Next question. Which of the following reacts with Hinsberg reagent and gives a product soluble in alkali? So which of the following will react with Hinsberg reagent and give you a product in alkali? Yes, which is the answer. So we know that what is Hinsberg reagent? Hinsberg reagent is what? It consists of what? It consists of your benzyl sulfonyl chloride. So which of the following will react? So with your Hinsberg reagent, it is your methanamine. Okay, methanamine will react with your Hinsberg reagent. Okay. So how they will give you the test? So with primary amine, okay, when you take your amine and you react it with your Hinsberg reagent, you are going to get a product, okay, which is soluble in alkali. With secondary amine, it is insoluble in alkali, and in tertiary amine, it gives you no reaction. So this is primary, this is secondary, this is also secondary, and this is the tertiary amine. So secondary amine, it is insoluble in alkali, okay, and this is no product. So our answer is option number A. They have asked which of the following will react, okay, and it will give you a product which is soluble in alkali. It is primary amine. Okay. Next question. Carbalamine reaction is given by carbalamine reaction is given by A. Primary amines, B. Secondary amines, C. Tertiary amine, all of this. Yes. So what is amine? This carbalamine reaction is given by whom? Yes, it is given by your primary amine. So what is the carbalamine reaction, student? You have to take a primary amine. Okay. We are going to react it with chloroform CHCl3. Okay. CHCl3 and potassium hydroxide. So what we are doing, carbalamine reaction, primary amines, they are we are heating. Okay, we are heating them in the presence of what? Okay, your primary amines, we are heating them in the presence of your chloroform, okay, and your alcoholic potash. Okay, we are going to take alcoholic potassium hydroxide. We are going to get what? We are going to get isocyanides. What we are going to get? Isocyanide. These isocyanides, they are having very bad smell. They are getting a foul smell. Okay, we are going to get a foul smell of this product of cyanide. Okay, so this reaction is called as a carbalamine test. So carbalamine test, they are given by primary amines. Okay, primary amines, both aliphatic and aromatic primary amines. Okay. Next question. The most convenient method to prepare primary amine containing one carbon atom less is. So which is the most convenient method to prepare the this Primary amine, yes, containing one carbon atom less, which is that reaction. It is the This is the reaction. It is the Hoffman bromamide reaction. Okay, it is the Hoffman bromamide reaction. So in Hoffman bromamide degradation reaction, what you can see, suppose I have a benzanamide. Okay, suppose I have a benzanamide. Okay, so CONH2. So this benzanamide, I'm going to react it with bromine. Okay, and alcoholic potassium hydroxide. Okay, what I'm going to get? I'm going to get a I'm going to get what? I'm going to get a aniline. Okay. Plus 2 KBr plus K2Cr CO2 plus 2 plus 2H2. Okay. So what I have got here? So I have got aniline. Okay. Similarly, if I take your acetamide. Okay. If I take this is our acetamide. Okay, so acetamide, so this is a aromatic. I have taken aliphatic. So reacted with Br2 in the presence of alcoholic, this what? Potassium hydroxide. What I'm going to get? CH3NH2. So what you can see in the uh, reactant and the product. So here the number of carbon atoms are 2. Here it is only 1. So you can see that there is a 1 carbon atom less. So this is Hoffman bromamide degradation reaction. So the most convenient method to prepare primary amines is by what? It is by the So this is also a primary amine. So which is the reaction? It is a Hoffman bromide degradation reaction. Okay. Yes. Let us go for the next question. Gabriel's phthalimide synthesis is used for the preparation of Gabriel phthalimide synthesis is used for the preparation of A. Aliphatic aromatic amines, B. Secondary amines, C. Primary aliphatic amines, and D. Tertiary amines. So we have seen this. So Gabriel phthalimide synthesis, it is used for preparation of primary aliphatic amines. Okay, they do not form primary aromatic, not secondary, and not tertiary. Okay, so why they do not form primary aromatic amine? Because aryl halides, they do not undergo nucleophilic substitution reaction. Right. So secondary tertiary is also not possible due to steric hindrance. So it is only the primary aliphatic amines. Okay. So it can be best prepared by Gabriel phthalimide synthesis. Next question. The reducing agent used to convert ethanamide to ethanamine is. So which is the reducing agent which is used to convert your ethanamide to ethanamine? Yes, which is that reaction, this reagent, which is the reducing reagent. Yes, the reducing agent which is used to convert your ethanamide to ethanamine is. It is the lithium aluminum hydride. Okay. So by using lithium aluminum hydride, you can convert your ethanamide, okay, to ethanamine. Okay, you can convert your ethane. So you can do the reduction. Okay, you can do reduction. So I'll give the reaction. So ethanamide CH3 C double bond O NH2. So this is your NH2. Okay. So ethanamide. So if you treat it with lithium aluminum hydride. Okay, if I treat it with lithium aluminum hydride in the presence of ether, I'm going to get what? CH3, CH2, NH2. So what I'm doing, reducing agent, addition of hydrogen, okay, and removal of oxygen. Okay, so lithium aluminum hydride. Okay, I hope you have got it. So you can do reduction. Okay, so what we are doing, we are converting our amide okay, to amines. So this is an amide and this is a amine. Okay, this is a amine. Okay, fine. Let us go for the next one. The least basic among ammonia, methylamine, and benzanamine is. So, which is the least basic among this? Which is the least basic among this following? Which is the least basic among ammonia, methylamine, and your benzylamine? It is what? It is C. Okay. Benzene is the this. Okay, because there is a steric hindrance. Okay, benzene is a bulkier group. So when you see the basicity, so first will be a secondary, then will be a primary, and then will be a tertiary. Okay, and then will be your ammonia. So it is your second. The least basic is your C, benzenamide. Okay, fine. Next question. So the reaction is given. So which is this name reaction? So which is this name reaction, students? It is your Gatterman reaction. Okay, it is your Gatterman reaction. So what is this Gatterman reaction? Anybody knows what is the Gatterman reaction? So what we do in Gatterman reaction, students? So in Gatterman reaction, what we do? We have a benzene disonium chloride, right? We have the benzene disonium chloride. So this is benzene disonium chloride. We react it with HCl in the presence of your copper powder, okay, cuprous powder, and it will give you a what? It will give you a chlorobenzene. Okay, it will give you a chlorobenzene. So this is your Gatterman reaction. So option number B. Okay, option number B. Yes. Next question, the best reagent for converting propamide to ethanamine is. So which is the best reagent to convert your propanamide to ethanamine? Yes, it is the NaOH in Br2. Okay, it is the NaOH in Br2. Okay, where you can convert your what? Your propanamide to your ethanamine. Okay. So let me write the reaction. This is a propanamide, okay, and we react it with NaOH and Br2, okay. We are going to get what? NH2. Okay, so I'm going to get a ethanamine. Okay, I'm going to get a ethane amine. Fine. So this is the reaction. So from propanamide, I'm going to get a ethanamine. So NaOH in the presence of Br2. Okay. Let us go for the next one. So this is a Hofmann degradation reaction. You can see one carbon is less, right? Aniline with a mixture of chloroform and alcoholic KOH gives. So aniline, okay, when you have a aniline, okay, and you react it with what? You react it with chloroform CHCl3 and your KOH, okay, that is alcoholic KOH. So what you are going to get when you react it with chloroform and your this, I'm going to get a aniline. Okay, so what I'm going to get? I'm going to get isocyanate, right? I'm going to get a phenyl isocyanate. So this is the phenyl isocyanate. Okay, isocyanate. So what is the answer? Option number B. Option number B. So aniline, when you react it with a mixture of chloroform and alcoholic OH, I'm going to get a phenyl isocyanate. Okay. Phenyl isocyanate. Isocyanate means what? your nitrogen is attached. Okay, your nitrogen is attached. So both the carbon and nitrogens are at the center. So when carbon get attached, they form cyanide, and when nitrogen get attached, it is called as isocyanates. Okay, yes. Fine. Let us go for the next one. Okay. So these were some of the questions. Okay. Uh, uh, Okay, so these were some of your questions. That is an MCQ question, so multiple choice question. So we have covered almost all type of questions. Okay, so out of 8 marks, okay, as you know, 8 marks are allotted for this particular chapter. Okay, you are going to get how many? You are going to get 3 MCQs. Okay, you are going to get 3 MCQs from this particular chapter. I hope you have got it. Yes, fine. So by this, I shall end this session here. So in the next session, we are going to see the 2 mark question. Okay, we are going to see the 2 mark question from the chapter Amines. I hope you have understood today's session. Okay, yes. So thank you, dear students. We'll meet in the next session. Thank you.